Hey, what's up everyone? Welcome to my stream. I think this is episode 24, or 24th stream. I've been working on Vectrexy on stream, so that's pretty cool. So today is a few things I want to look at. So one of the things I did since last stream is I was able to get the render for the emulator working a bit better. So you can see here that it's looking actually pretty good. I'm able to move my ship here in Mindstorm. I can fire. And it looks pretty good, right? I can die. Then this ship comes down. Now you see there's this bit of jitter going on with the ship there. I would love to understand what's going on there actually. Like if I'll die again, and I'll just break here. See if I can get it. There. See, like a frame like this. Here we can see that there's this crazy overdraw, right? Like basically 1, 2, 3, 4, 5, like 6. It's as though the Vectrex had time, like the CPU had time to draw 6 frames before my main display loop had a chance to render it, which is relatively surprising to me, because I am here trying to clear at a frequency of 50 Hertz. So basically whenever 1 over 50 seconds elapse, I go ahead and I clear the display, the lines that we need to draw. And if that is indeed the way it works, we shouldn't be seeing this kind of overdraw. At most, what I expect to see is like one, like perhaps part of one screen and part of the next screen being drawn. A little bit like how over here we can see the end of a line, but it doesn't continue. I expect to see maybe 2 parts because I'm not synchronized with, like, my 50 Hertz display here where I draw and I clear is not synchronized with the actual 50 Hertz that the CPU is trying to stay at. You know, they can be completely offset, which would mean that we would see like the lines from last frame and the beginning of the lines from next frame or so. But that's not what we're seeing, so I'd like to try to understand why that happens. So one thing I want to do for that is take a look at, there was a function for that. Let me see here. Weight recal, that's it. Resets to the 16-byte value stored at here. C8 3D. Well, that's surprising. GTA 3D. Oh, there it is. $75.30. Okay, so it is 7530, which is 30,000 cycles. T2. So let's see what gets stored into T2. Hey, ho ho ho, thanks for the follow. Appreciate it. So there's the 30,000. Okay. So let's see if we can figure out. What I'd like to do is take a look at the weight recal here. Wait for T2. So that's what happens is we end up staying here, and then when we're done, we come to set refresh. We go here, set refresh. So we should be at F182. Break at F1, was it F1A2? Interesting. Let me see here. I think this should be 1 over 100 actually. Okay, this might be working now. Yeah, there we go. There was something funky with my timing there. So now we can see that we're not getting like more than 2 sets of renders. It's very jerky, and that's more to be expected. This is what I expect to see. Because we're not synchronized, it's going to be like jerky like that. But at least, yeah, this didn't make any sense what I was doing here. I need to be clamping at basically a maximum time that makes some sense. And basically, like, for example, when I'm debugging and I'm broken into the debugger, I'm going to have a huge delta time, right? And like, let's say we want to maintain 60. So like that's like, you know, 1 over 60 is 16.67 or 0.016 seconds. I was thinking milliseconds, right? So let's say 16.67 milliseconds. It's about 33 for 30 FPS, and 10 FPS is 100 milliseconds. So that's what this is about. It's saying if our delta time is really large, then what we'll do is we'll go into slow motion and we'll just clamp our delta time to be 100 milliseconds, so that when we step, we're basically stepping at 10 FPS in that case, where every frame is 100 milliseconds. Whereas before, what I had it is I was stepping and I was only stepping 10 milliseconds, which is like crazy fast, right? So yeah, so that was not making any sense. It needs to be not faster than 50 Hertz, which is what it was. Okay, now I'm curious about if I could actually kind of do a little hack here and have it clear when we know the game expects it to be cleared. So how could I do that? Let me think. So, okay, let's just try it with a hack and see if it actually would work. if clear lines equals false, and we'll extern this bool over here when we write to timer 2. Basically, when we reset timer 2, which is what happens here, and no, not here actually. Where does it get reset? Oh, here, store into timer 2. When F1A5 gets executed, at that moment we know we've waited for recalibration and we can clear the screen. I mean, none of this is correct. Interesting. Doesn't quite look as good as I would have thought. Fascinating. You know what it could be? Actually, let's do this differently. I think what's going on here is that we're executing a bunch of instructions, and so we will have already tried to draw some lines by the time we get to the render. I think that's what's going on. Yeah, that would make sense. What am I doing? Okay. Yeah, actually, maybe instead of doing this, we have access to our lines. Right here, we're in the via. So let's say I just forced and cleared here. And we forget about clearing the lines in this function. And actually, we need to actually draw them. So we'll draw them every time we call render. Okay, that doesn't look good. Curious. Oh, right. Of course. I need to not just clear lines, I need to clear the screen. So I'm gonna hack that up. How do I do this? I know how. Again, this is a huge hack. I just want to see if it'll work the way I expect it to. Without LNG out. Oh yeah. Same thing. Curious. It doesn't really make a lot of sense. Basically, at the point when the Vectrex calls wait recal and then eventually set refresh here, because it drops into here, it should have done a full frame of drawing lines. So it's a good place for me to clear all the lines, clear the screen, and start the second timer so that in the next 30,000 cycles we draw the next bit of lines, which we continue to draw throughout. I might just be missing one more draw before I clear. Maybe that's what we're seeing right now. And that's very possible. Let me see if I could do this differently. I think if it makes sense for the VIA to know about to display, but no, it doesn't really. Oh, okay, I have an idea. Because I do know that I'm okay, I'm gonna undo this crap here. I know that I am calling. I don't need any of this. I am going to be calling the display. Am I? Let's see if I'm right. I'll say if the vias lines dot size, or if the line is empty, then okay, if it's empty, clear the display, draw the last bit of lines. Oh, it's already been cleared. Okay, I'll do it differently. Instead of emptying it directly, set a flag that we want to do that, and then in here we'll check the flag. So if clear lines, set it back to false, then we'll do this. Let's see if that works. Doesn't look like it. Still flickering. It's a bit more stable though, but no, look at that. So I think what's happening here is what I was saying before. If I go back to STL engine, the way we update the debugger, oh no, that's it. I call client update and then I call render. And the thing is, update may update such a large number of instructions that I may get into the next frame. And that's part of the problem, isn't it? Okay, so basically what's happening is, if I can draw this, okay, so basically if we think of it like a red line is whenever we are drawing where the CPU is saying I need to make a vector, and I should have chosen this color, but basically this guy here what the hell? Okay. Okay, so basically what's happening is that I don't know like I could be executing this many instructions, and in the middle of that, I'm gonna hit the setting of like the end of the frame, basically like when the timer 2 gets set again. But then in the same delta time, in the same time step, we may actually end up saying draw more lines. And then when we reach here, my code says, okay, now it's time to render because we've done a full frame of up like a certain slice of delta time. So go ahead and do your draw. But by here, if I go and clear, because this says, oh, go ahead, clear the screen, I lose this bit here. I lose the drawing of these lines, and that's the kind of flickering that we're seeing. Now, in reality, this won't be much of an issue because what I'm supposed to be doing is not clearing the screen. I'm supposed to be drawing the vectors and having the vectors kind of fade out over time. And that will kind of happen naturally because I'll be drawing to a buffer, and then I'll be taking all the pixels of that buffer and bringing them down back to black over time, just like on a real CRT. Now, so far, I mean, I'm kind of faking it now with a bunch of draw lines, so I was hoping that I could get a close approximation, which is what I have, but not such a twitchy one. So I don't know if it's worth trying to make it behave a bit better or just wait until I actually do the proper drawing into a buffer like I was saying. My idea is to kind of draw to it, render to a texture, and then have like a pixel shader take those pixels and bring them down and write back out to the texture and render that. Yeah, I don't think it's worth trying to fix this just yet. But this is good. I'll keep the 1/100. Basically what it means is I have this kind of like ghost shadow. But it's not the end of the world because at least we can see the lines for the thing we care about. Actually, what happens when I turn this on at the same time? Oh yeah, so that's one weird thing I noticed in Mindstorm is the very first time the ship passes, it only produces dots in like this area here, which is super odd. Because if I kill myself, the next one he'll give the more expected even spread. You see? It's really just that first time. Like, see now if I die again, the stars end up again evenly spread out everywhere. See again, it's evenly spread out. I have one more ship left. so weird. I actually went through a ship there, didn't I? Oh, right there. I mean, I went through an asteroid. Okay, it says game over. So what if we start again? See, now it's spreading fine. It's really like if I restart from scratch, the very initial state, there's something wonky with the initial state that causes it to put all the stars in the upper right quadrant or so. It's not quite the upper right quadrant, I think, because there's a few that make it below, but all on the right side anyway. See? Look, all on the right side. Yeah. And then no lower than here. Now we get a bit more even spread again. So that's something odd that's going on here. Okay, so what I'm going to work on is keeping in mind that right now I'm not even using my CPU implementation. I'm using the one, the alternate one, right? So if I switch, it's called use Vectrex. I switch back to mine. One of the things I know is that is wrong is the number of cycles, because here we see all the writing is slanted. So I'd like to fix that in my CPU implementation. And let's see how the game plays. Oh wow, that was strange. Oh whoa, that's interesting. And see, like there's like this crazy overshoot. Yeah, that's it. When I move right, yeah, there's clearly a bug in one of my instructions. This is what I was looking at, thinking about, was something to do with a probably add with carry that's not working, something like that. So see, that's really funky, and the ships don't appear when I use my CPU. So the way I'm going to debug that is really simple. I'm going to use my trace output with and without my CPU, and I'm going to just diff them and see where it differs. So first we'll do that just to try and fix that like add with carry bug that we have. So we'll go into my debugger here. I'll change the initial state to say start tracing. So this way when we launch, it'll start the trace output right away. Like that. Now maybe what we'll want is we'll want to trace up until a point. And what I'll say is let's do it up until till Mindstorm starts, right? Bad cart load Mindstorm address. So it'll be here basically. Ready to play the game. E000 into U. Jump into cartridge. Yeah, that's right. I'm trying to remember here where exactly it jumps. FE07. Sorry, FOE7. that's really slow. I'm going to run and release because in debug it does tend to go really slow once I set a breakpoint. There we go. So we should hit that breakpoint fairly soon. No? Oh, here we go. Breakpoint hit. Okay, that's it. We start the card at E016. So I'd say it's safe to start tracing from there. I mean, possibly later than that. But let's start from there. So what we'll do is we'll load symbols, we'll break here, then we'll turn on trace, and continue. So in that case, we will not start in the debugger, and we will not have trace enabled. So when we start, we'll load symbols, set a breakpoint, trace, then I guess we'll disable or even delete the breakpoint, and then we'll continue. And at this point, we should start having trace. I have a batch file to launch this here somewhere. Where did I stick that stuff again? Here. Trace disable. I guess I didn't build. Oh yeah. Okay, let's try it again. So, I mean, I'm kind of expecting to see the trace here. There it is. So if I do this, run, and I'll say my CPU 1, let's see if we're getting, yeah. Is it working? Strange. Really strange. Load my symbols, set my breakpoint. Oh, set the breakpoint. Continue. When we hit the breakpoint, turn on trace. Actually, delete the breakpoint, turn on trace, and then continue. So Let me try it like this. I do need, okay, yeah, I need to initially start by breaking into the debugger so that I can execute this stuff. Yeah, that makes sense. That's why it's not working. Let's see. Okay, that already looks better. It's loaded, breakpoint, added breakpoint there. Now ostensibly I've continued. It's possible that we're getting buffered output here. Okay, there we go. So it is being buffered. Man, that was extremely slow. Trace enabled. I guess that's it, right? With the trace enabled and flushing to a file, it's gonna be slow. 60 megs. My frame rate's dropping. Yeah, it's like too slow with the trace. But you know what, let's see how far we get even with just this trace. So I feel like we're not getting enough. Oh, one thing I could do, maybe to speed this up. Let me try something. I was wondering if like the part of actually printing I wonder if I was to remove this, if it will make any difference. I don't suspect it'll make much of a difference, to be honest. Actually, I should probably build that. But if I remove the part of my output here, this part here, and just leave the very first part, the disassembled instruction along with the address, the hex instruction, and the disassembled version, but not the comments nor the description here, if that'll be any faster. But probably not much faster. Now it's gonna go super slow. Yeah. Okay, even though I have only this, let me just try now to capture using the other CPU and just making a diff between the two, because that might actually be enough to give us information. Just let it run a bit. Okay, so this one ran just a little bit longer. So let's take these two and diff them. Oh, and we see differences already. Fascinating. So we consistently have one difference here, which is that on Vectrex we end up with an extra bit of time over here. So this is probably timing related. It has to do with cycle counting. So what we'll do is let's print the number of cycles that are elapsed in the debugger, and that will definitely show us a difference. Or it should anyway. Okay, I guess I can put this back. So if we want to print the number of cycles, how do I do this? Print op here prints the current one, but we haven't executed it yet. So I guess I'll print the cycles, the cycle after executing it. Okay, yeah. You know what? I won't put actually. I'll do something like this. I'll just put like what this means is it'll print the number of cycles, but because the instruction's already been printed with a new line, it'll print the cycles for the previous line. But that's fine. I know that's the case. So it would be nice to actually print the elapsed cycles when we do this. And if that's what I want to do, I'm going to have to make it so that print op doesn't actually print a new line here. Yeah, maybe I'll do that. I don't know. But for now, let's just keep it simple. So we'll say actually, this is a UN64, so I'm gonna have to do like something like this. Is it ULL? LLU. Okay, that's what it is. So let's see what that looks like when we run it here. So if we look at the output now, 75 megs. Yeah, maybe 75 megs is a bit much. So maybe I will go back to because I mean we get lots of stuff from the comment and the like we're getting a much bigger file because of that, which is just making it annoying and long to look at it. Okay, it's gonna start here. 3, 4, 5, 6, 7, 8, 9, 10. Still pretty big. Maybe it's 10 seconds as long. Okay, you know what? But again, we'll just count to like 5. One, 2, 3, 4, 5. Okay, 50 megs. Seems a bit more reasonable. Okay. Okay, Notepad is really crunching here, so let me just get that out of the way. Okay, now we're going to do my CPU. This is built, yeah. You can tell it's mine because of the crooked letters. Three, 4, 5. Yeah, about the same size. Let's check now. Okay. We're not getting them in line because of the buffering, I would assume. Does that make sense? It doesn't make that much sense, to be honest. It's interesting because already we can see here 4, 8, 7, 7, 2, and here there's a 7 for me, where there's a 6 for Vectrex. But I need these next to the instructions, so why are they coming out this way? Print off, execute instruction, which would print this. Printf. It's the same thread. Why would this be happening? Where are my instructions? It's like as if the instructions did not get printed at all. So there's like a huge number of lines. Or, it's like one big line. Doesn't make any sense. Oh. Why does this one look correct? What is going on? This is super strange. Okay, I know what's going on. I know exactly what's going on. The printf that we're doing it regardless of whether trace is enabled or not. Showing the number of cycles. I need to be only doing that if trace is enabled. Okay, that makes way more sense. That's why we had so many at the beginning, but eventually we start to see instructions. In fact, we had one long line of them. And that's why in Vim, when I stepped to the next line, we could see it, so. Okay. This is gonna make more sense now. 1, 2, 3, 4, 5. There we go. See, and as expected, the very first one here does not have the number of cycles, so that's fine. We know that 3 here is for the previous one, and 8 is for the previous one here. Interesting how clear X plus took 8 cycles. Oh, that's interesting. Okay, so now we'll run again with the Vectrex implementation. Does that work? One, 2, 3, 4, 5. Wow, almost exactly the same size. Okay, so right off the bat, it looks like my CPU reports one more cycle for TFR ADP, and also another one for RTS. Also, I report one less for this load X. Very interesting. So we'll take a closer look at these now. Actually, I'm just gonna go to the washroom. I'll be right back. All right. So let's take a look at why RTS is 7 for me and 6 for Vectrex. So this is op RTS. Okay. CPU opcodes. So I've got 5 here. So I'm going to get 5 for that. Try to remember how cycles are done. So that's the base cycles for the instruction. So there's the 5. Now I have extra cycles depending on if we do indexed EA. Anything else? There's, okay, there's push and there is pull, okay, for the stack. Long branch gets a cycle, but RTS doesn't really fall into that unless, what? Yeah, what's going on there? Okay, so let's go ahead and debug what's going on when we do an RTS and see how we get to the 7 cycles. So F1 B3. So we are at F1 B3. Let's put a breakpoint in execute instruction. Oh, gotta be in debug, yeah. So we run in debug. So we'll set a breakpoint in my Vectrex debugger. We are there. Now we have our breakpoint here. No, what's going on here? Why won't it see a breakpoint there? Oh, right. Because I'm actually not using my implementation right now. That makes more sense. Let's try that again. Okay, so we set our cycles to 0, and we'll just put a data breakpoint for when this gets changed. And a breakpoint for when we return it. Alright, so there's the first pop, and there's the 5. So it should have been 5. Oh, sorry, I'm such an idiot. It is 5 for RTS. It's TFR that we want to look at. Yeah, okay. TFR A to DP, and this will make more sense. I said that I would realize that the cycles go with the previous line, and I made the mistake right off the bat. It's awesome. Okay, so break actually on this instruction. Whoops. There. So we should be doing a TFR instruction right now, as we are at F1 B1. Yeah. F1, B8. Okay, we jump to the subroutine. BSR, branch of subroutine 49. And then we are at F1AF. And then at F1B1. There's a load AC8, yeah. So we're about to do a TFR ADP. So there it is, TFR. So we're gonna get 7 right off the bat. Is that? So I have 7 for that, while he has 6. Why is that? Yeah, 7. Is that not correct? Let me check my my instruction notes. There's 7 for TFR here. And then, oh, this one says 6. So I guess depends which table you check. Oh, it looks like it's 6. I have 2 sources that say 6 and only one that says 7. And this one here is more interesting because it shows what's actually happening cycle by cycle. So I'm gonna go with what they're saying and just change this to 6. Alright, that was easy. Let's move on to the next one. Alright, here's a jump instruction that took 3 from me, but was considered 4 by Vectrex. Now a jump is 3 for me. So what made this one 4? Is it because, it must be because it's a, maybe there must be an extra cycle for making a jump, a long jump like this. Yeah. This is page 0. I'm gonna guess as a page 1 jump, or no, it's always here. I mean, we have long branches, but not long jumps. But this is a jump to a 16-bit address. So let's see here. That would be, what kind of jump is that? 7E. 7E is here. Extended mode jump. 3. Read extended. Contents of 2 bytes following opcode bytes specify 16-bit effective address. Always a 3-byte instruction. So maybe when I do read extended, this should be an extra cycle. See what my notes say. Here we go. So jump. Direct addressing is 3 cycles. Three for direct addressing. Looks like for extended and index, it's extended it is an extra cycle, whereas index will depend on the index mode. So that I think I handle, but I'm not doing it correctly for extended. So basically what I should be doing, I think, is just setting this to 4 for extended, not 3. Let's see if that coincides with what is said here. Here jump says 4, but see, that's not necessarily accurate. 70. Yeah, I guess in the case of 70, because they don't have jump for direct. See here, in this table, it always says 3, whether it's extended or not. I don't think I can trust this one too much, even though this is the one I actually based my table on. But the cycle one here is the most interesting. I'm going to use this one as my basis for cycle. So we'll put 4 in there. Anything else? Ah. What about this one? Oh no, that's a TFR again. Okay. TFR. So here I have a pull S that's different. -7. Here it was 8. One, two, three, 4. Pull 0 to 12 bytes. So I have 5 base cycles, which should be 1, 2, 3, 4, and looks like this last one here. And then in between, the extra ones will depend on what happens. This is immediate, because pull S is always an immediate mode instruction, but it is treated specially. This is pull. That's it. The number of bits that are set determine 1 cycle per value that's pulled. So maybe I'm not quite doing this right. Let's check this out. Because it should be 5 plus, if we're pulling 3 bits, for instance. Actually, can we figure it out from here? Pull S. See, that's just 2. So then that should be 7, which is what I'm doing. It's basically 1 cycle per byte that we pull. Ah, but the PC counts for 2. Ah, that's right. If we do a pop 16, right? Pull S PC is 6 cycles. So that looks like the basic 5 plus 1. Okay, let me check. Maybe in where is it? Why isn't this working? Oh, there we go. Just a rendering issue, I suppose. So there's the base, 5 plus some kind of little 4, 2. Trying to understand. Okay, this just means 5 plus, like 5 cycles plus some amount extra. Let's try it here. Push and pull instructions. From here, I think what I'm supposed to be reading here is we have 1, 2, 3, 4 for the first 4 cycles. We do this opcode fetch, the post byte. We don't care, we don't care. Then it's going to pull either from 0 to 12 bytes depending on which bits are set in the post byte, which is basically 0 to 8 registers. And what I think I'm seeing here is that for each one, it's 1 cycle for 1 byte. That's what this looks like, because it's saying that SP will basically be moved. The net effect here is that here we write to SP, and then here we write to SP plus 1 to SP plus 2. So if we're pulling a 2-byte value, then that means 2 of these will have happened. And I mean, I suppose that makes sense, right? So what I did here doesn't make sense. Counting just 1 cycle per bit doesn't make all that much sense. And we have X, Y, DP, and PC that are all 16. I'm also wondering, just in general, when these guys are called, maybe the cycle count increment should be happening in the pop16, you know? But then I gotta have to change more code because the base number of cycles for each one takes those into account, generally speaking. So if I was to attack this a different way, that's what I would do, is I would get rid of the base number of cycles and really try to figure it out based purely on what each instruction is supposed to do. But that's not the avenue I went down, so let's see if we can just make this work. So basically, probably the simplest thing to do here, and I'm guessing it's the same thing for pushing. We have 3 that are 1 byte and 4 here that are 2 bytes. Okay, let's try this. If the number of bits set in what was it again? Oh no, it's in my bit operations. If we read value, but we mask in only bits 0, 1, and 2, those are basically 1 cycle instructions. But here for 3, 4, 5, 6, and 7, it is 2 cycles for those. What is it that it doesn't like? $6.95. Oh, right. And it should be the same thing here. Wasn't it M cycles? It was. Oh, I should probably type M cycles. Okay, so let's give this a try. We'll have built here with my CPU. We'll run it again. This time I'll write it to number 2. Aha! This is looking better already. The font is now straight, so that's a good sign. Four, 5. So now, if we go in here, okay, we're at parity now, and at least in this case. So that's great. So let's play a little bit more. Let's see what the game looks like now. Now I know there is also a difference with oh yeah. So now what we should see is that there's still that bug. Actually, you know what? Let me run release. Yeah, that looks so much better. Okay, so this is still messed up, and I'm gonna guess that, yeah, I still got the weird ship moving stuff, and they're not spawning. So what I need to do now is I need to kind of figure out a way to start capturing trace from here. Okay, what I can do what could I do? What I could do, let me try and run the Mindstorm ROM that we assembled. There I actually have code, right? So there I could put a more useful breakpoint on exactly a line that we know it gets executed when the ship starts to move and stuff, hopefully. So let's do that. So now we're talking ROM source Mindstorm new, right? Or is it this one? Yeah, it's this one. Yeah. So let's just see if this even works. We'll give it a path to the ROM. Okay, this is good. We've got very similar behavior. Awesome. So let me see here. We have listing here. Actually, maybe this one's better. No, not quite. Okay. I know that I was able to generate a full listing when I did the BIOS. Let me just go see how I did that. Minus T minus P. It's the same thing. Oh, there we go. I guess I had not rerun it since I updated the batch file. Okay, so here we have the source code for Mindstorm. So let's see if we could find a place, a good breakpoint for us in here. Initialize Minesweeper, game level sequencer. Entry for level restart. Initialize for game level, min lay. Subroutines, handle mine laying sequence. So that's probably the beginning where all the mines get laid. And then we go to S-play. So that sounds very interesting. Not display, but S-play. Here. F6, F68D, really? But in our case, it'll be E68D because this is an actual compiled ROM and not the BIOS. So we'll try E68D. E68D. Let's see if it breaks just when it's about to start gameplay. Did not hit my breakpoint. Jump to subroutine. E68D it should have been. I mean, unless it really is. Oh, wait. So it's not E, sorry. Yeah, okay. 0 in the ROM space. So what is S-play? F68D, that's a BIOS instruction. And it's music. Oh, okay, yeah, sound play. Okay, so I thought this was... This has to do with music. Mine laying tune, okay. So I was, that has nothing to do with what I care about. Draw a left packet, draw a right packet. So this will be interesting here to debug why we're not getting left and right packets. We can get the answers here. Draw explosions and ship counter. Setup for tune. Grow 4 large mines. Maybe here. 019E. But actually we want during the time that it's laying them. That's a good part to check because it's... We'll probably find a bug there related to the same thing. So yeah, let's try here. Deposit initial line 015E. Up, breakpoint hit. And now if I hit continue, okay, so this is good. This is a good time to start doing a trace. And in fact, we can disable that one and then stop tracing probably here at 019E. Disable that and then break at 019E. No? So this was good for the deposit of initial mines, but I thought it would reach here, but it did not. Or is it just I didn't wait long enough? Oh, because we're never... We must be stuck. Where are we right now? F13. AD7. 0B03, 0B06. Wait for frame boundary and input from controller. Zero AB3. 0AC0. Where is this? Draw active player scores. Okay, so whatever. So I do want to start capturing from here, but I guess I need to stop when. Let's see if we can figure out a good place to stop here. Skip if zoom value is 0. Ah, okay, so here we're decrementing the value in *1, and then here we load into B, and when it becomes 0, the equal flag will be set, so we should be jumping to here. So maybe that our bug right now is for some reason that's not happening. Really, the only thing that can get us out of here is this branch of equals here. That's the whole point. But I guess we're not getting here. Anyways, it's okay. What we can do is we will put our tray still here, and then I'll just kill it myself, and that should give us what we need. Yeah, that'll be fine. So we'll go to input here. So we'll load our symbols. We'll set a breakpoint to this guy. Continue. When we break, delete it, set the trace, and continue. Okay, that looks good. So now we have my CPU. So let's go here. This will be, and actually we need to modify run to run my ROM. Like that. Do I need to put quotes? Maybe not. But I'll put them anyway. Okay, so let's see how this goes. There we go. Now we're capturing. And we'll stop because there's a few coming out here. All right, so we have a 28 meg file. That's good. So now let's put back Vectrex's CPU. So let's try to capture about the same amount for the Vectrex CPU and see if we can figure out where the difference is. Here we go. Alright, pretty close. So let's diff these. Alright, right off the bat we're getting some differences. So more cycle differences actually. So see, it's weird. Perhaps my assumption about 2 byte cycles for... Oh wait, is DP 2 bytes? Did I make a mistake? I think I made a mistake. DP is just 1 byte. It's the direct page register. XY, U, S, PC. DP is... Oh, okay. Okay, so that explains that guy. I'll pull CC, A, B, and DP. So there should be bit 3 in here. So it's even a bit more symmetric this way. basically half the registers are 8-byte while the other half are 8-bit, and the other ones are 16-bit. Okay, so is that pretty much what all these differences look like? Push, push, yeah, push, pull. Okay, so that's not gonna help me very much. So let's try that again. Just overwrite this. This will be Vectrex this time. Captured a bit more this time, and let's go back to our own CPU. Okay, let's go back to Beyond Compare. Ah, that's interesting. So now this is more what I was looking to see, is differences in behavior. So see, we would have run all this time up until we got to F5E9, where we're doing a branch if not equal 1, and in my case, we went to F5EB, whereas here we went to F5EC. So that's either, it can be many things here. Let's see, is this the first time F5E9 appears? It's not. On every second one, we have a different behavior. Unless it's just that we're somehow offset. Let's see. Oh yeah. How would that be? So the difference we see happens in the function rotate VL mode A. So let's see what that is. Here. This routine rotates a vector list having the following format. The A register contains the rotation value and the X contains a pointer to the vector list. The U register contains a pointer to a buffer into which the transformed points are to be saved. Rotation angle value points to the original vector, U points to the rotated vector list. F5, E9. Okay, but we actually return from... Oh no, sorry, that calls 61F. Right, vec angle, yeah. So now we jump to DP to C8, return. So where are we here? F5 EB. We're in the get rise index. We saw that. Okay, we would have seen it if I had my comments here. Compare A branch if not equal F9 F5 E9. And A, compare A, branch if not equal to here. So in my case, they would have been considered equal. Mask to multiple of 180 degrees. Why does adding 16 decimal offset angle by 90 degrees? If A is really the angle value, bit A with 20, and if the angle is in 180 to 360, high byte is obtained by masking the angle with 0x1f. This forces the angle to be between 0 and 180. Okay. F5, E5. Hit my breakpoint already? Oh yeah, that makes sense. Alright, okay, and then A is 0. So if we end A with 1F, it's just going to remain 0. Actually, I should have checked that before. Yeah, so A is 0. It'll remain 0. We're going to compare it to 1, 0. So when we compare it here, negative flag got set. That makes sense? Maybe it does, actually. Because I think compare takes the value and subtracts A. Is that correct? Let me see. Pop compare. Subtract to update CC but discard result. Right. Subtract impl. So it looks like what we're doing here is we're saying subtract reg, is it A minus compare A minus S. So 0 minus 10, yeah, that would make a negative value, wouldn't it? It would indeed. F5, E5. Compare A if 90 degrees. So branch if not equal. So not equal is looking at what? We're looking at the 0 flag. Well, the 0 flag is not set. So we should be branching here. Branch if not equal. So branch of 0 is not set, which is the case for us, right? So we should in fact go to LF5EC, so to F5EC. And we did. But that's doesn't look like what we had in our This is my CPU here. So why did I make it to F5EB here? Let me see something. Okay, so we do hit F5, E5, technically before we hit the real breakpoint that I set in my trace output. Huh. I think what we're seeing here is just a offset in what the result is supposed to look like here. Yeah. What this might mean is that the actual error occurs earlier than when I'm breaking, when I'm capturing my trace. And now things are kind of offset. Okay, well, maybe we're capturing too late then. Let's try with this guy. Try with Vectrex. Okay. Okay, this compare is looking a bit better, actually. Looks like syncing a little earlier was the right thing to do. Okay, so this is interesting. The load B instruction here, which is an indexed mode instruction, Vectrex only reports 9 cycles, where I report 12. That's very interesting. And then that would explain why we end up with why the Vectrex one ends up with an extra bit A branch if equal here, because it has more cycles that it can use to execute instructions, I suppose. Yeah, that would make sense. So there it is again. And okay, this is something else. This is jump subroutine. Again, indexed mode. I'm definitely reporting more cycles for indexed mode instructions. This is jump subroutine, this is load B. So anytime there's an indexed mode instruction, I've got like 3 more cycles here. And then here, this is very interesting. Branch if not equal. Okay, well we end up on different instructions here, so that's why these are different. One and CCs and one or CCs. Okay, so let's focus on the reason for index mode looking different. So index mode. Okay. We'll start with the fact that load B we're looking here at E6. So it's the index mode one. Ostensibly starts with 4 cycles. So let's go take a look in our docs for that. Here, load B. So load B, and we said it was definitely indexed mode, yeah. So we've got opcode fetch, the post byte, then something based on index mode. So we're not getting the 4 here. Here, load says it's 5 in this table. 6. So for load accumulator, this guy is saying it should be 5. Why do I have 4? Since mine is based off of this table. Oh, because I'm not doing it. So immediate would be 2, index register would be 4, 4, 4. Oh no, that's wrong. Direct would be 2, indexed would be 2, extended would be 5. Extended. So basically loading a regular accumulator is apparently 5 cycles. Loading a double accumulator is 6. Loading a stack pointer is 7, but loading the user stack pointer would be 6? What? Oh, different ones in here. So you have load B versus load D. There's definitely an extra one here, for reading the next byte. Load D, load U, load X. So these ones would have the same amount. So 1 extra. Load... Oh yeah, look at that. Load S does take... Load S and load Y do take an extra cycle. Why? Oh, because of the... opcode second byte? Really? Opcode second byte. What? Oh yeah. Because these guys are in op... No, that's page 1. Oh yeah, page 1, that's right. So grabbing from here adds a cycle. Okay, yeah. So if I look here, see if I can make some sense of this. For example, if we compare load Y to load X, that's what we should be doing. Split this here. So load X here, direct, is 5 cycles, whereas load Y, do I have a load Y direct? Yes, is 6 cycles. Load X immediate is 3, whereas load Y immediate is 4, so it makes sense. That's direct, indexed is 5, and indexed is 6, extended is 7, extended is 6, yeah. So this makes sense, but of course we're not interested in that one. We're looking at load B, so if we come back to load B here, here we have 4 for a direct, 4 for indexed, and 5 for extended. So does this make sense? So we're looking up here. Yeah, so this is the guy. Load B. So load B for start at the top. Immediate would be 2 cycles, yeah. That makes sense. Direct 4. Direct 1, 2, 3, 4, yeah. Indexed. So indexed is strange because it shouldn't necessarily be okay. Yeah, so it's 2, and then based on index mode, it's some number here. But here we're saying 4. So that might be wrong here, putting a 4 for indexed mode here. Yeah, so that's questionable. And then finally we have the load B extended, which says 5, and then I think that makes sense. 1, 2, 3, 4, 5. Yeah. And we looped around here to immediate. So I mean, if this were 2, that still wouldn't give us what we expect. We would be, instead of at 12, we'd be at 10. So there's still a question there of whether or not the number of cycles we're computing for indexed mode makes sense in this case. Like, we can't account right now for the 3 cycles. Maybe we're accounting for 2, given that we might want to set index to 2 plus based on indexed mode. I mean, this is definitely the most complicated. So which one are we dealing with? I'm not even sure. I'm gonna have to put a breakpoint on this guy here. F6, F0. I'm gonna have to stop soon. But we're making great progress here. We fixed a few bad cycles and got our text straight. I think we're getting much closer now. So here we are. Oh, not in debug. I think we're suffering from the atrocious frame rate, but anyway, that's okay. Alright, so here we are. Trace. Turn this on. Step. Here we are. So there's load U. Oh, yeah. Wanted load B here. Give this one go, and if I don't see it, I'm gonna stop and we'll continue this in 2 days. Should be fine. Okay, so there's load B indexed. So that's, right now I'm saying 4 cycles here, but that's maybe 2, probably 2. So here we're going to load. Now here we're going to do our read operand value. That's going to bring us into our indexed here. So let's see where we end up in here. So we're going to be computing extra cycles. So it's all about. Okay, so we're doing address indirect only. So here I'm adding 5 cycles. Is that correct? Probably it's 4. Now where did I get this value from? Let's go look in our book. Or maybe I have it in here. Index addressing mode variations. So actually this here looks like it would be useful. For opcodes 10xx and 11xx cycle, and PC has to be increased by 1 to get correct values. PC. So this I think means the 2 different opcode tables, but cycle and PC has to be increased by 1, right? Okay, 1 extra cycle, move the PC by 1, makes sense. So we are looking at just an address. This 1, 2, 3, 4, 5, 6. So there's the 4 basic, maybe? Oh no, we did cycles 1 and 2. 3, 4, 5, 6, 7, 8. 1, 2. So, in fact, this actually looks like I should be adding 1 more cycle. See, like, notice how they all start on cycle 3 here, because it does assume 2 cycles initially for the instruction, I suppose. Let's see if this kind of matches up with my other values, because it looks like it doesn't. Let's say R++. Register ++ here. I put 3 extra cycles, but oh, sorry, here. 1, 2, 3, 4. Five extra cycles. Oh, +3 in here. Okay, so that's interesting, because now I need to read and combine those. Go back to this, because I really am here. So what did I just do is I did a read PC8, read PC8. So sorry, just keep moving around. Read this byte, those are the 2 addresses. Then there's a don't care. Then there's an indirect high, indirect low. So this does feel like this should be 3 plus 3 more here. For here is another indirect, it says high and then low. Although I guess I'm reading them in reverse order, but it doesn't really matter. So those are the 2 bytes here, and then there's a don't care byte. So that's like a don't care cycle. So it should be like 3 plus 3, which is 6. And I'm doing like 5 plus 3. This is probably 3. I don't know why I have 5 here. So if that were the case, I would reduce this by 2 and the other one by 1. Then that would actually bring us to parity. We would go down by 3. But then see, it puts into question all of these ones here. I suppose the reason why I put 5 here is because, like, technically, when you do this one, you're supposed to read these and immediately do the indirect stuff. This probably should have been 6. I don't know why it was 5. But in my code, I set supports indirect as true, and the post byte will take care of reading indirectly from the EA here. So I suppose that's why. This should be 3. So this one here is very fishy. I'm going to take a look at that. And let's say we go back to our opcode table and we say, yeah, this should be 2. So that should fix that one case that we're seeing. Let me just take a look here. Plus or minus 15 with PC. Yeah, because you can see all the ones where there's indirect, you have to add 3 more cycles, right? 3, 3, and that's exactly what I do at the bottom here. I always add 3 more cycles when it's indirect, so that's fine. So now what I'm looking for is here, 16 NPC. 1, 2, 3, 4, 5, 6. 7, 8, 9. So actually, it's like I'm missing a cycle even. Comma R. There's a don't care cycle there. Shit. Comma R plus and comma R minus. 1, 2, 3. I got 2. So I've always got 1 less than what they're showing. Why is that? Is that the, oh, probably because I've already counted the PC plus 2. Could it be? Plus PC plus 1. Not sure. No. 8n plus r. Plus r, so it's that one. It's like I always have 1 less cycle. Let me try running from my CPU again and comparing. See, now I messed up any other load B that actually was 5 cycles. Does that make sense? I think that's not it. I think it's like this. This goes back to 4. This, instead of being 5, it should be 2. Because all of mine here have 1 less cycle than what I see in that table, so not 3. That still won't make sense. 5, 6, 7, 8, 9, 10. I think I'm going to need to think this through a little bit more. And of course, you know, I'm guessing that Vectrex is correct in its cycle counts, but I don't know for sure. Oh. Well, that gives a much cleaner difference. Okay, that's super interesting. That's really interesting. So now we've got the same cycle count. So I guess what I did now was right. That's what I thought. But then we get to this point here, and there's some logic up here that's not working right. Probably OR B is not doing what we expect. Because you see here, we executed all this code, and then all of a sudden, we have a split in behavior here. The flags are not being set the same way. There's definitely something going on here. Okay, so now it's midnight, so on that note I'm gonna stop the stream. So those of you who've been watching, thanks for watching, and I'll be back in 2 days, so Wednesday night, 9 p.m. Eastern. So hopefully I'll see you here. Take care.